Hello friends, welcome back. In this session, we will slowly get into Six Sigma and we will learn that step by step. This session is going to serve as a foundation for you to understand the Six Sigma stuff. It's going to be easy and interesting. Well, let's get ourselves introduced to Six Sigma. The first and foremost point here that we need to understand is it is a quality improvement methodology. Six Sigma is a systematic, disciplined, and data-driven methodology aimed at improving quality by eliminating defects and minimizing variability in the process. The term sigma refers to standard deviation, a statistical measure of variability. I repeat, the term sigma refers to standard deviation, a statistical measure of variability. The core idea here is that if you can measure how many defects you have, you can systematically figure out how to eliminate them and get as close to zero defects as possible. I again repeat, the core idea is very simple. If you can measure how many defects you have, you can systematically figure out how to eliminate them and get close to zero defects as possible. Six Sigma provides a structured framework using methodologies like DMAIC, which stands for Define, Measure, Analyze, Improve, and Control, and that helps to go ahead driving continuous improvement. That's the first point. It is a quality improvement methodology. Second point, it is data-driven and customer-focused. Unlike the older systems that may rely on intuition or broad assumptions, Six Sigma places data at the center of decision making, which means everything is data driven. Every improvement initiative is grounded in statistical evidence and process data. It is also deeply rooted in understanding customer needs. That is what is referred as CTQ, critical to quality. The goal here is to design processes that deliver exactly what the customer wants consistently, always with minimal defects or minimal delays. That's the second point. It is always data driven and customer focused. Then comes the third point. It seeks to eliminate defects and variation. Six Sigma aims for near perfection by identifying, analyzing, and eliminating causes of defects and reducing process variation. Variation is the enemy of quality. Remember, variation is the enemy of quality. A process that is too variable will produce inconsistent results leading to customer dissatisfaction. The tools which we know, like the fishbone diagrams, the control charts, the Pareto analysis, and the root cause analysis, are used to pinpoint sources of error. For an example, in manufacturing, this could mean reducing the number of defective parts in services. It could mean faster and error-free processing of customer requests. So, we seek to eliminate defects and variation. The next point, Motorola is the one who developed it, and this was popularized by GE. Six Sigma was pioneered by Motorola in 1980s, where it significantly reduced defect rates and saved billions of dollars. Bill Smith, an engineer at Motorola, is often credited as father of Six Sigma. It gained global popularity when Jack Welch of General Electric, GE, made its central business strategy in the early 1990s. GE reportedly saved over $12 billion in just 5 years by implementing Six Sigma across divisions. Six Sigma is always equal to 3.4 defects per million opportunities. We call it DPMO, defects per million opportunities. The name Six Sigma comes from the statistical concept of being 6 standard deviations away from the mean, which translates to a process that produces only 3.4 defects per million opportunities. This extreme level of precision ensures high reliability and performance. To put it into perspective, if airlines use Six Sigma standards, only 3.4 incorrect luggage deliveries per million would occur. Achieving Six Sigma performance requires process capability, CP by CPK analysis we call, and measurement system analysis, MSA, and other statistical rigor. And finally, Six Sigma is applied across the industries. like the manufacturing, services, healthcare, and where not. While it started in manufacturing, Six Sigma has evolved into cross-industry methodology. In the healthcare, it reduces medication errors, it improves the patient outcomes, and streamlines hospital workflows. In finance, it's used to improve accuracy in billing and reduce transaction processing errors. In retail and e-commerce, it helps reducing return rates and optimize supply chains. Even government and education sectors have strongly adapted Six Sigma to improve service delivery and reduce waste. That way, Six Sigma is very useful and it's good to learn that. Well, let's get into the next level where we need to understand the key concepts of Six Sigma. First term that you need to understand here is CTQ. CTQ is critical to quality. CTQs are the measurable characteristics that are most important to the customer. These are key performance requirements your process must meet to satisfy customer expectations. For example, in a pizza delivery service, CTQ should be delivery time under 30 minutes, the pizza temperature, and order accuracy. Identifying the critical to quality helps prioritize improvement efforts on what matters the most. The second one is defects and defect opportunities. A defect is an instance where the product or service fails to meet customer requirement. A defect opportunity is any chance within a process for a defect to occur. I repeat, a defect is any instance where the product or service fails to meet customer requirement. A defect opportunity is any chance within a process for a defect to occur. For an example, in a hotel room service, delivering food cold, late, or wrong counts as separate defect opportunities. Six Sigma definitely aims to reduce defects per million opportunities, which is often cited as DPMO. The third one is variation and process capability. Variation is the enemy of quality. We cited this early. It refers to inconsistencies in process output. Process capability measures how well a process can produce output within specification limits. A process with a low variation and high capability is predictable and delivers consistent results. A bottle filling machine, for an example, that always fills 500 milliliter plus or minus 1 milliliter is highly capable. Then comes the voice of customer. VOC represents customer needs, expectations, and preferences. It is captured through surveys, feedback, complaints, and interviews. It drives requirement gathering and CTQ definition. Example, customers might say, I want faster service. This VOC becomes a CTQ like service time less than 5 minutes. Next, Y is equal to F of X, which is nothing but output is a function of input. This Six Sigma principle means that the outcome Y always depends on multiple controllable factors X. To improve Y, which is the result, you must identify and control the critical X's, which is nothing but inputs. Example, in baking a cake, which is nothing but Y, the inputs X include oven temperature, ingredients, and time. This equation encourages focus on process inputs, not just results. Remember, we need to focus on process inputs, not just results. And then comes the process thinking mindset. Six Sigma encourages you to work as series of interconnected processes, not isolated tasks. It is series of interconnected processes and not isolated tasks. This mindset helps find root causes. Most importantly, it helps us optimize steps and reduce waste and rework. Instead of blaming individuals, it looks at how the process can be improved. It promotes the culture of continuous improvement by analyzing the end-to-end workflows. So, the key concepts here are critical to quality, which is CTQ, defects and defects opportunities, variation and process capability, voice of the customer, which is VOC, Y is equal to F of X, and then process thinking mindset. These are the key concepts of Six Sigma. Alright, it is time for us to understand in brief the DMAIC framework. It is nothing but define, measure, analyze, improve, and control. Altogether, we call it DMAIC framework. Let's go into this with a brief note on each of this. First step is define. You need to identify problem and customer needs. This phase focuses on scoping the problem clearly, defining the business case, and identifying the voice of the customer. You create project charter very clearly, identify the CTQs, and set goals and boundaries. For an instance, a call center defines its problem as high call abandonment rate during peak hours. It ensures that the customer's expectations and the business objectives are aligned before moving forward. Second is measure. You need to collect the baseline data. In this phase, we quantify the current state of the process to understand its performance. You define metrics, validate data collection systems, and measure DPMO or process capability. The check sheets, run charts, control charts, all these are the tools that you can use here, and an example would be app. You can measure the average waiting time and call drop rate over a month to get the baseline performance. The next one is analyze. You need to find the root causes of the defects. Here, you diagnose the process to understand why defects or problems occur. Techniques like the fishbone diagram, 5 whys, Pareto analysis, and hypothesis testing are widely used. Focus is on identifying the critical X, which is nothing but the inputs that affect the Y, which is the output. Example, you can discover that long wait times are due to inefficient call routing and lack of staff during peak hours. So the next one is improve. We need to implement the solutions here. Based on the analysis, the targeted solutions are designed and tested. The tools used for this stage are the brainstorming, the FMEA, which is failure mode and effects analysis, and design of experiments, which is called DOE. The pilot solutions can be implemented and the data can be collected to validate the improvement. Example, introducing callbacks, reschedule staff to peak hours, and optimize scripts to reduce call handling time. All this can really be very helpful for you. Then comes the fifth stage, which is called control. You need to sustain the gains. This phase ensures the improvements are standardized and maintained. You need to develop control plans, standard operating procedures, we call it SOPs, and monitoring systems. You need to use the control charts and dashboards to detect variation and avoid sliding back. An example would be implementing a real-time dashboard for call volume and wait time with automated alerts if thresholds are exceeded. That way, you can control and you can also sustain. So what are the 5 stages in DMAIC framework? Let's quickly summarize whatever we have learned till now. D stands for define, M stands for measure, A stands for analyze, I stands for improvement, and C stands for control. You need to identify the problem and customer needs at definition stage. You need to collect the baseline data at measurement stage. You need to find the root causes of the defects at analyze stage. You need to improve by implementing solutions in the improvement stage. And finally, you got to sustain the gains in the control stage. With that being said, it's important to understand the sigma levels and DPMO. The first one is 1 sigma. It is 6,90,000 defects per million. At 1 sigma, the process is highly inconsistent, with nearly 69% of output being defective. This level may be acceptable in process with low cost or low risk, but definitely not suitable for high stake industries. Example, please imagine 6,90,000 errors in credit card transactions per million. That's completely unacceptable for financial systems. The second level is 3 sigma, where 66,800 defects. It's industry average. 3 sigma is often considered the industry average for many processes. This means that 93.3% accuracy is there, but still over 6.6% defects are 66,800 defects per million opportunities. Let's take a retail context. This could mean 66,800 wrong deliveries per million orders. It's a huge cost to reputation and customer trust, and this is also unacceptable. Then comes Six Sigma, 3.4 defects. It's near perfection. At Six Sigma, only 3.4 defects per million opportunities are expected. This is called 99.99966% quality, which is the gold standard for process performance. Achieving this level often requires sophisticated statistical tools and a culture of excellence. This is used pretty much in the aerospace, healthcare, and semiconductor manufacturing, where failure can be fatal or extremely costly. Then comes the higher sigma. It is better process capability which is connected to it. The process capability, which is CP by CPK, measures how well a process can produce output within defined specification levels. The higher the sigma level, the more consistent and reliable the process is. Less variation leads to better capability. Better capability leads to fewer defects. Fewer defects leads to improved customer satisfaction. That's what we need. Next one is the benchmarking. The benchmarking for world-class performance. Many global companies like the Motorola, GE, Honeywell, Amazon adapted Six Sigma to reach and maintain world-class standards. Six Sigma certification is often a requirement for leadership roles in quality and operations. It is not just a methodology, but it is a benchmark for operational excellence. Trust me, it is not just a methodology, it is a benchmark. Then comes translating Sigma to business impact. Reducing defects will save millions in rework and warranty claims, customer churn, and lost opportunities. A simple example, a 1% error rate in airlines baggage system. It is equal to 10,000 mishandled bags per million. At Six Sigma, it just drops to 3 or 4, which means this leads to improved customer loyalty, lower cost, and higher efficiency, and stronger competitive advantages. Executives often use Sigma level as a KPI when assessing operational performance. So what are all the levels we have seen here? 1 Sigma, 3 Sigma, 6 Sigma. 1 Sigma has got 6,90,000 defects per million. 3 Sigma, 66,800 defects, which is industry average. Then comes Six Sigma with 3 or 4 defects, which is near perfection. That's what we learned in the slide. Let's get into the roles in Six Sigma. We will start with the executive leadership. These are the top level executives like the CEO, COO who initiate and endorse Six Sigma across the organization. They align Six Sigma with business strategy and allocate resources. Their commitment sets tone for cultural adoption across departments. For example, the CEO of GE, Jack Welch, was pivotal in making Six Sigma a corporate mandate. So these guys are the executive leaders. Second is the champions. Champions are the senior managers who act as sponsors for Six Sigma projects. They help identify high impact projects, remove the roadblocks, and most importantly, ensure that teams have the necessary support. They act as a bridge between executive leadership and project teams. Think of them as the owners of success at business unit level. Then comes the master black belts. These are the top tier Six Sigma experts with deep knowledge of methodologies and statistics. Their role is more of mentoring. They will mentor the black belts and green belts. They conduct training. They ensure projects follow the proper Six Sigma framework. They also help in standardizing tools and best practices across the organization. For an instance, if a black belt gets stuck in the root cause analysis, the master black belt can step in and he can offer help. Then comes the black belts. Black belts are dedicated full-time professionals leading high-priority projects. They drive process improvement using DMAIC and advanced statistical tools. They work across the departments. They influence the change. They report their progress to the champions. For an instance, a black belt may lead a project to reduce production downtime by 30% within 6 months. Then comes the green belt. Green belts are functional experts who support Six Sigma projects alongside their regular job duties. They often work under black belts and contribute domain knowledge and data. For an instance, a green belt from the HR might analyze employee attrition patterns in a retention improvement project. Finally comes yellow belts. Yellow belts are the team members with fundamental basic Six Sigma training. They understand the fundamentals, they assist with the data collection, and they support improvement efforts. They are ideal for staff who are involved in day-to-day execution of tasks being optimized. They form the organization foundation for building quality culture in the organization. So what are all the levels? Executive leadership, top row. Champions, next. Master black belt, next to it. Black belts, subsequent to it. Green belts, and then finally yellow belts. We have seen all these, and I hope you understood the roles in the Six Sigma very clearly. What next? We need to understand the tools that are used in the Six Sigma, and that is where we are going to head next. It is time for us to understand the tools used in Six Sigma. One is SIPOC diagram, which stands for suppliers, inputs, process, outputs, and customer. Suppliers, inputs, process, outputs, and customer. It is a high-level process mapping tool used during the define phase of DMAIC. It helps the teams understand the entire flow of a process before diving into improvements. For an instance, for an online order system, the supplier is the website backend, input is the order form, process is the validation, and payment output is the confirmation. And customer is the buyer. SIPOC sets clear project boundary and it helps. The second one is fishbone Ishikawa diagram. It is also referred very commonly as cause and effect diagram. This tool helps identify possible causes of a problem. It categorizes the causes under major headings like the man, machine, method, material, measurement, and environment. It is very much suitable and ideal for the analyze phase to support root cause analysis. An example would be handy, right? Yes. It is used to understand why a product is frequently returned, and the causes may include poor packaging, unclear instructions, or defective components. The next one is the Pareto chart. Based on the 80-20 rule, we can understand that 80% of the problems come from 20% of the causes. A bar chart plus line graph combination that helps prioritize issues based on the impact. An example would be in customer complaints, if 3 issues causes 80% of the complaints, you fix those first for maximum gain that you can obtain. Pareto chart helps focus the effort where it really matters the most. Then comes the histogram and box plots. Histogram shows the frequency distribution of data that is used to spot the skewness, the spread, and the central tendency. The box plots really show the spread, median, quartiles, and outliers, thereby offering a quick summary of data variation. These are very, very critical during the measure and analyze phases of data visualization. An example would be very helpful here. Measuring cycle time across teams and identifying if one team's variation is significantly higher is going to be very helpful. Then comes the control chart. It is used to monitor process stability over time. They plot a metric, for example, call duration, over time with upper and lower control limits. We call it UCL and LCL. This helps distinguish common cause variation from special cause variation. For example, a daily manufacturing output we can consider, and if a data point crosses control limits, it signals a quick process shift or abnormality there. It is essential in the control phase very much. Then 5 whys and FMEA. 5 whys is a very simple but yet a very powerful root cause analysis tool. You can ask why 5 times to drill down to the real issue. Example again is helpful. Product delivery is delayed. Why? First is transport issue. Second why? Route not optimized. Third why? No GPS. And so on, and finally you get to zero in to the point. Then comes FMEA. FMEA is failure modes and effects analysis. It is a proactive tool to identify potential failure points and prioritize them based on risk priority number. We call it RPM. So we can use all these as tools in Six Sigma and we can improve and control things better. So what are the tools? SIPOC diagram, fishbone diagram, Pareto chart, histogram and box plots, control charts, 5 whys, and FMEA, which is failure modes and effects analysis. All these are real good tools which are proven to be worthy, and we can definitely try using them in the Six Sigma. Let's understand the benefits of Six Sigma. This reduces defects and rework. The primary benefit of Six Sigma is its laser focus on eliminating defects and minimizing process variation. Fewer defects mean less rework, reduced waste, and faster delivery, all with higher consistency. For an instance, in manufacturing, reducing defect rates from 5% to 1% saves both material and labor costs dramatically. Less rework leads to smoother workflow and increased productivity. Second biggest advantage of Six Sigma is it improves customer satisfaction. When your processes are consistent and defect free, customers get what they want on time with high quality. Higher satisfaction leads to repeat business, positive word of mouth, and higher customer retention. Example, airlines that apply Six Sigma to baggage handling significantly reduce lost luggage, which is a key customer pain point. Then comes cost. Six Sigma helps you saving cost and increase revenue. Six Sigma cuts down operational costs by eliminating inefficiencies. It also opens opportunities to generate more revenue by improving product or service delivery speed and quality. Example here would be handy. GE reported over $12 million in savings through Six Sigma over a period of 5 years. This makes it a strategic tool for financial performance. Then Six Sigma drives data-driven culture. Six Sigma shifts organizational decisions from opinions to insights. It trains teams to rely on measurable evidence, not assumptions, to improve processes. This also promotes the use of tools like control charts, hypothesis testing, and statistical analysis. Six Sigma encourages a culture of accountability and continuous learning as well. Most importantly, Six Sigma enhances employee engagement. Yes, more employee engagement will lead to success. Involvement in Six Sigma projects gives employees a chance to contribute to meaningful improvements. The roles like green belts and yellow belts empower staff with ownership and responsibility. This often leads to higher morale, recognition, and career growth. Staff in healthcare organizations use Six Sigma to suggest improvements in patient care protocols. Finally, Six Sigma helps scalability across functions. One of the most powerful features of Six Sigma is that it's not limited to manufacturing. It applies to finance, HR, sales, logistics, healthcare, education, government, and IT. For example, in a hospital, it reduces patient wait times. In IT, it improves incident resolution rates. It's truly cross-functional. It's truly scalable. And it integrates well into any organization's strategy. Let's quickly compare Six Sigma versus Lean. The Lean focuses on speed and waste elimination. The Lean methodology aims to maximize customer value by eliminating non-value added services, which are like waste. Waste includes overproduction, waiting, transport, overprocessing, inventory, motion, and defects. There are 7 wastes here which I listed. Lean improves process flow, speed, and responsiveness. An example, a hospital applying Lean reduces patient waiting time by streamlining admission and discharge processes. Coming to Six Sigma focuses on variation reduction. Six Sigma, on the other hand, focuses on reducing process variability and defects. It uses statistical tools and structured problem solving like DMAIC to ensure consistency in the output. Example could be helpful. Let's consider a bank. Six Sigma might reduce errors in loan approvals by analyzing and controlling inputs. Lean is the flow. Six Sigma is the quality. A simple way to remember is presented here now with you. Lean ensures the process flows quickly and efficiently. Six Sigma ensures that what flows is accurate and defect-free. Lean focuses on process speed, while Six Sigma focuses on process precision. Together, they are a great combo and they create fast and flawless systems. Now, organizations often integrate both methodologies as Lean Six Sigma to harness the best of both worlds, which is the best idea. This hybrid approach eliminates waste while also improving accuracy and reliability. For instance, a car manufacturer uses Lean to reduce assembly time and Six Sigma to minimize paint defects. Finally, the complementary approaches come into picture. Lean and Six Sigma are not competing, they are complementary. Where Lean may identify waste, Six Sigma can dig deeper into root causes using data analytics. Together, they are a great combo, as I said, and they form a complete process improvement strategy which can help the organizations grow. They are widely used together in the modern enterprises, and today Lean Six Sigma is a standard in global companies like GE, Amazon, hospitals, banks, governments, and where not. It leads to faster operations, better quality, happier customers, and higher profitability. Many certifications now offer the Lean Six Sigma bells combining both the approaches. That shows how important it is. So, Lean and Six Sigma are complementary and they are not competing with each other. Quickly, let's understand some of the case studies which are going to help us in understanding the value of Six Sigma. Motorola saved over 16 billion using Six Sigma. Motorola was the birthplace of Six Sigma in 1980s. By applying rigorous process improvement, they saved over 16 billion, especially in manufacturing and supply chain. It improved reliability, reduced warranty costs, and enhanced customer satisfaction. GE also made a huge savings here, and under the leadership of Jack Welch, GE made Six Sigma a mandate. They saved a lot of money too. Amazon uses Six Sigma in warehouse operations. Amazon applies Six Sigma to optimize its massive warehouse and logistics networks. It reduces error in order picking, packing, and shipping. Altogether, this ensures customer orders are accurate and are delivered on time. Hospitals improve the patient care and reduce errors through adaptation of Six Sigma. And most importantly, banks. Banks use it for loan processing efficiently. In the banking sector, Six Sigma improves turnaround time for loan approvals. It reduces errors in documentations and ensures compliance. Example is very helpful here again. A bank can apply Six Sigma and they can reduce the mortgage processing time from 28 days to 14 days dramatically. And finally, call centers use it to cut handle time. Call centers use Six Sigma to reduce average handle time, AHT we call, and they improve the first call resolution, FCR we call, and they minimize escalations. More efficient agents reduce customer frustration, lower operational costs, improved efficiency overall is what Six Sigma is going to get you. Alright, so let's quickly summarize all the benefits. Six Sigma is a combination of quality plus data plus discipline. Think of Six Sigma as a formula. Quality mindset, data-driven decision, discipline through structure and methodology. It is not a buzzword, it's a rigorous system that creates real impact. Then focus on improvement. As its core, Six Sigma is about making processes better, faster, and more reliable. Whether it's a factory line or a billing system, the goal always remains the same, which is continuous improvement. Third, based on reducing variation and defects. Six Sigma is always based on these factors. Variation causes inconsistency, which leads to errors and dissatisfaction. Six Sigma minimizes this through statistical analysis and process control, striving for near perfect products. And finally, we have got other area to look into. It uses structured tools and roles with defined phases like DMAIC and the tools like SIPOC, Fishbone, Pareto. It brings clarity, and what more is needed? You get clarity, predictability comes into picture, and Six Sigma works across domain. Whether you are in manufacturing, healthcare, finance, retail, or tech, Six Sigma will apply. Let's discuss your questions in the chat, and I'll be very happy to answer your questions. If you have anything, please go ahead and type it in the chat section. I'll be very glad to assist you with my answers. Thank you very much.